This is Geometry Unit 3, Lesson 3 on parallel and perpendicular lines. We are going to look at slope as it applies to parallel and perpendicular lines. So, let's take a look at lines K and L. Here's line K, here's line L. Now, if we want to find the slope of line K, we just have to find 2 points on the line and then count to get to the next point and figure out the slope. So, let's find a couple points. Let's say I've got a point right here, and I've got the y-intercept right here. Now, we know this is going to be a positive slope because the line is going up, but how do we go from left to right, this point to this point? We have to go up 2, 1, 2, and over 1, so your slope is 2 over 1, which is 2. Okay, now, as you travel from left to right along line K, how does y change each time x increases by 1 unit? All right, well, let's try it out. So if I'm right here, and if I go over 1, I've got to go up 2. So, if x increases by 1 unit, y increases by 2 units, because that's what's happening with the slope. As x increases by 1, y will increase by 2. So it's up 2 over 1. That's your change. All right, now let's look at the slope of line L. Here is line L. If we want to figure out the slope of line L, let's see if we can find 2 points. Here's 1 point, and let's see, find another point. How about right there? There's another point. So looking at from left to right, going from here to here, we have to go up 2, 1, 2, and over 3, 1, 2, 3. The slope of line L is 2/3. Now, if I look at this a little bit closer, as you travel left to right along line L, how does y change every time x increases by 1 unit? Well, every time you go over 1, how much do you go up? All right, so here is a closer view. This box right here is just a closer view down here. So here is this point right here. The y-intercept is actually right there. So this is over 1 unit from here to here. How much did the y go up? Well, over 1 unit, you went up. Not all the way to 1, we went about 2/3. So when you're actually going up, if you think about that, y is going to increase 2/3 of a unit for every unit that you go up, or go to the right, excuse me. Y increases 2/3 of a unit. So that should tell you something about your slope. For a non-vertical line with a slope of m, each time x increases by 1 unit, y will change by whatever m is, m units. So if your slope is 2/3, if you go over 1, you're going to go up 2/3. If you go over 1 again, you're going to go up another 2/3, or whatever slope it happens to be. So if m is positive, that means y is going to increase. Your line is going to go up. Your line goes up. What if m is negative? What if your slope is negative? Well, that means that y is going to decrease, which means your line goes down. So the value of m, the slope, is a very important thing. It tells you how you move from point to point on the line. And for every increase of 1 unit in the horizontal distance, the x value, your y value is going to go up or down depending on if m is positive or negative. Now, let's see if we can apply that. For the line, 7x plus 4y equals 12, what happens to y each time x increases by 1 unit? What are they really asking you about that? They're asking you about the slope. So we need to know what the slope of this line is. How are we going to do that? Well, the easiest way to figure out the slope is to put it in y equals mx plus b form. So to get in y equals mx plus b form, we subtract the 7x on both sides. So you get negative 7x plus 12, and then divide by 4. And you get y is equal to negative 7/4 x plus 3. Okay, so if that's in y equals mx plus b form, what is your slope? Your slope is negative 7/4. So that means if your slope is negative 7/4, every time you increase x by 1 unit, what happens to the y? Well, this is a negative 7/4, so it's going to be decreasing. Y is going to be decreasing by 7/4, or 1.75. or 1.75 units. So every time you move 1 to the right, you are going to decrease 7/4 or 1.75 units down because of that. So your slope is telling you how to move every time you move over 1. Now let's look at parallel and perpendicular lines. There's some special properties of the slope that happen when you have parallel and perpendicular lines. So let's see if we can explore those. So I have my two lines here, K and L, that are graphed on our axes. Let's find the slope of line K. Remember, to find the slope, all you have to find is 2 points and then count from left to right. So let's pick, say, here and there. There's 2 points that I know for sure on the line. So let's count. We go from here, 1, 2, 3, up, 1, 2, 3, 4, over to the right. So up 3 over 4 means the slope of K is 3/4. Now, let's look at the line L. If I pick, say, this point here and this point right here, there's 2 points. So I'm going to go from here to here, 1, 2, 3, up, 1, 2, 3, 4, over to the right. So up 3 over 4 means my slope is going to be 3/4. Now, based on what we know about slope, will the lines ever intersect? Think about this for a second. I have these two lines. They both have a slope of 3/4. So will they ever intersect? No, they won't. The reason for that is each time x increases by 1, what's going to happen to y? Well, y is going to increase by 3/4. So they are actually increasing at the same rate. So are they ever going to intersect? So it's happening at the same time, so that's not going to work. They will never intersect. If they're both moving at that same slope, they're never going to intersect. So that means that those two lines are parallel. So I can say that line K is parallel to line L because they have the same slope. Now, parallel means they're never going to intersect. Now, perpendicular, we know from the last unit, is perpendicular lines make right angles. So I'm going to draw a line N perpendicular to line L at the point 4, 1. 1, 2, 3, 4, 1. It's this point right here that I just picked. Okay, now, you want to draw perpendicular, you want to make a perfect right angle when you do this. So if you are going to draw a perfect right angle, you have to make your ruler look like a T to go right up here. You've got to be really, really careful when you draw it. You want to make sure it goes up, makes a perfect T when you do that. So there is our line. So if you want to figure out the slope of this line, this is going to be line N, you want to be able to count from one point to the other. So I know this point is on there, and if I count from here to here, 1, 2, 3, 4, 1, 2, 3. Now notice this line is going down from left to right. So when I go 4 here, this is actually down 4. 1, 2, 3, 4, 1, 2, 3. The slope of line N is negative 4/3. So what do you notice about the difference between the slope of line L here, that was 3/4, and the slope of line N right there, that is negative 4/3? What changed? Well, you can see that the slope changed by its sign, first of all. It was positive, and then the new slope became negative. So it's going to be the opposite sign. And also, 3/4 became 4/3. The slope is the opposite reciprocal. So perpendicular lines have opposite reciprocal slopes. The slope is the opposite reciprocal of the other line. So perpendicular lines have opposite reciprocal slopes. So we had to flip the slope and change the sign for it to be perpendicular. So those are our two rules that we're going to talk about with parallel and perpendicular. These are our important facts. Parallel lines have the same or equal slopes. So if two lines have the same slope, we can automatically say they're parallel. And perpendicular lines have opposite reciprocal slopes. So if you know the slope of a line, you also can figure out the slope of the line perpendicular to it by using the opposite reciprocal of the given slope. So if AB is perpendicular to BC and the slope of AB is negative 3/4, what is the slope of BC? Well, we need to do the opposite reciprocal of negative 3/4. So we want to flip and change the sign. Flip and change the sign. So negative 3/4 becomes positive, and then flip it 4/3. So any line that is perpendicular will have an opposite reciprocal slope. Parallel lines have the same or equal slope. So what we're going to do is we are going to apply this reasoning to figure out some problems. So let's try an example. We have quadrilateral ABCD that has vertices at A, B, C, and D listed here. And we want to know if line AD, which is this line right here, is parallel to line BC. Now, you don't want to say, yeah, it must be because they look like they are. No. You says explain why or why not. Well, what do we know about parallel lines? Parallel lines have the same slope. So, well, let's see if we have AD and BC have the same slope. So I'm going to use M for slope of AD, the slope of AD. So to find the slope of AD, I need to use delta y over delta x, or I can just count on the graph. Let's use delta y over delta x just to make sure we got it. All right, so I got to use A and D for my points. So change in y is going to be negative 4 minus 2. Change in x is going to be 3 minus negative 1, which is negative 6 over 4, which is negative 3 over 2. So the slope of AD is negative 3 over 2 for this line right here. If we count, 1, 2, 3, 1, 2. Yep, that works. 1, 2, 3, 1, 2. Yep. Okay, now let's look at the slope of BC. So I know which one I'm talking about here. Delta y over delta x. Using the points B and C. 1 minus 4 over 4 minus 2. 1 minus 4 is negative 3. 4 minus 2 is 2. All right, so are these parallel? Yes, they are. Now notice I did this work here, but I haven't explained anything. I did lovely work, but it doesn't explain why it says. What you'd have to do is explain to me why this is true. We can say right here, AD is parallel to BC because they have the same slope. You can't just say they're parallel without saying why. You have to say they are parallel because they have the same slope. So those two lines are parallel. Now, is angle A a right angle? Explain why or why not. Well, in order to figure out if A is a right angle, this angle right here, if that's a right angle or not, what would have to happen? Well, AD would have to be perpendicular to AB, correct? All right, well, if AD is perpendicular to AB, then it would be a right angle. Well, we know the slope of AD we found up above was negative 3 over 2. Now, what is the slope of AB? This line right here. That's the other line that would be make it perpendicular. Well, the slope of AB is, let's see, A is negative 1, 2, and B is 4, 2. So that's going to be 4 minus 2 over 2 minus negative 1. 4 minus 2 is 2. 2 minus minus 1 is 3. We have AD is negative 3 over 2, and AB is 2 over 3. Are those opposite reciprocals? Yes, they are. So we can say that AD is perpendicular to AB because they have opposite reciprocal slopes. And that makes angle A a right angle. And angle A is a right angle. That explains why that is a right angle. You do the work and then explain why you did the work. These are called coordinate geometry proofs. It's used to prove stuff. So, you need to know your rules for slope, parallel, and perpendicular for tomorrow.